Welcome to the first Math 110 video. In this video, just to kind of show you and tell you how things are going, you're going to have a series of notes that you can print out, and I'm going to go through these notes with you. I may not go over everything, but I'm going to go over most of it. There's going to be some things I'm going to ask you to do and just basic practice. So this is basically your lesson. However, there is a distinction I need to make. To my online class, you may print these out and follow the video if you want. It may help you in your studies. However, I don't require you to do that because you've got a lot of material that you can go through. This is just something to help you. However, if you are in my campus course, this is a required video, and don't forget that you have to print these notes out and bring them to me the next class day or when they are due. Okay, don't forget that. That is very important. So online students, this video is completely optional. The notes is completely optional. However, for my campus course, you got no choice. Okay, now with that said, let's go ahead on to it. The first thing that we're going to be talking about in this video is basically what we call estimating. We all have heard estimating before, but this is the best definition I like to give. Estimating is an educated guess. All right, it's not just a guess, it's an educated guess. I can guess your age. Your age is 4. All right, well, that's not very educated now, is it? Now, I could probably do an educated guess and say, hey, your age might be 18. Well, that's pretty good because you're in college. I know that. But since I'm talking to you directly, I don't know anything else about you. But now if I'm going to talk to you in person and I know you're in college, I see your facial features and everything else, weight, size, everything, I can probably guess your age with that little bit of education. That's the difference between a guess and an educated guess. So that's kind of what I want you to understand. When I estimate something, I'm doing it a guess that's educated. So let's just go right straight to the first one. Now, I'm going to read these questions. You can read along with me, and we're going to try to use some common sense in this stuff. All right, it says, Chandra hires 11 people to pick crops from the field. She agrees to pay them $2.50 for each unit they pick. Estimate the total amount of money she will have to pay if each person picks 6 units. All right, so quickest way to doing this is just to go ahead and start multiplying things out, but I don't want to do that. I want to make an estimate on it. So I'm going to be lazy here, and I'm going to just say, instead of 11 people, let's just say she hired 10. All right, she hired 10 people, and she said that each person picks, I don't know, 6 units, right? So if each person picks 6 units, and I'm estimating 10, well, that means 60 units were picked, right? Well, then it tells me in this problem that each unit was $2.50. Well, what's $2.50 close to? Well, $2.50, we can round it to $2, but I round it up to the nearest dollar. Let's say 3. So 60 units, and every unit is about 3. Well, that gives me 180. All right, that's using common sense. So I just kind of got an estimate. So what are my possible answers? I have 1,500. That's a stupid answer. Throw it out. The next answer, $300. Okay, maybe. Next answer, $15. That's a stupid answer. Are you only going to pay 11 people a total of $15? No, you're not. That's a stupid answer. Throw it out. The next answer, $150. Hey, that's kind of close to what I estimated. So guess what the answer is? $150. Now, what I just did, I just kind of did some very simple math, some very simple educated guesses, nothing all that hard. Now, you may have decided to do it another way, and that's fine. You could actually get $150 as an answer. Really, for this problem, there's multiple ways of solving it. Don't freak out. All right. Next one, number 2. A box of 7 items costs $27.88. Find the cost of each item. Okay. Before we even do math, let's just look at the answers. 4 cents. You're going to buy 7 items, 4 cents a piece, and it equals to $27? No, that is wrong. That makes no sense. Cross it out. $8. All right, 7 items, $8 an item. 7 times 8, what's that? That's 56. Does that make sense? No, it doesn't. Rule it out. Next number, 40 cents. No, think about this one again. Well, it might be, I don't know, but that's only 7 items. Let's think this one again. 7 items for 40 cents. Is that anywhere going to possibly come close to $27.88? Probably not. The last one, $4. Well, what's 7 times 4? Well, 7 times 4, 2 times 7 is 14, times 2 again is 28, so 7 times 4 is 28. Did that work? Yes, it did. Okay? Now, you may have just looked at this problem and went like that. That's fine. No problem with that. Just want you to see how this works. All right? Now, a tip, 15% tip on a meal costs $20.63. Okay? We need to figure out how much we're going to give the waitress or waiter. All right. A, $3.15. That's possible. B, $4.73. Also possible. C, $31. You are not going to give a waiter or a waitress $31 as a tip unless they really, really look good and you need a date later on that night. So we're going to rule that one out. D, 32 cents. You are not going to give somebody 32 cents. Frankly, if your waiter or waitress does not do a good job, are you going to give them 32 cents? No, you're going to give them nothing. So rule that one out. So what's that leave me? A and B. So let me do something here. We can do some math here. We can throw, but let me show you something my dad taught me a long, long time ago. Is 10%. You can find 10% of any number by simply moving a decimal. So what we're going to do is concentrate just on 10%. But not only that, let's make it a little easier. It says that we have $20.63. Well, what's that close to? That's close to $21, right? Now, my dad told me a long time ago that if I wanted to find 10% of a number, I just find where the decimal is. Like, here's the decimal on 21, all right? And I simply move it this direction. What did that tell me? It tells me that 10% of 21 is equal to $2.10, all right? $2.10. Now, here's the next thing. Did I want 10%? No, I wanted 15%. Well, if this is 10%, how do you think I can find the additional 5? Well, half of 10 is 5, so I guess I could probably half that. And I can. Half of 210 happens to be $1.05. Well, this represents my 10%. This represents my 5%. What am I going to do? I'm going to add it together. $3.15. So my answer happens to be A. Cool. That one actually matched our work. Now, could we have done this another way? Yes. There's multiple ways of doing it, and that's fine. All right. This next one, you may have printed this out already, and you may have black and white, so I'm going to just kind of show you mine. It actually has the color on it, so if you need to, pause the video, and we'll just talk about it. You can just kind of write down what colors are what. You got like pink, orange, green, blue, and like a purple. So now, this is straightforward. This is you interpreting the graph. All right. First off, what's happening in this graph? It says population by age. and it gives me a couple things. That in 1900 I have all these different age rates. I have under 5, 5 to 24, etc., etc. Those are all the different age ranges. I have in the 1900s, the 2000s, and then in 2050. Okay. Now, then it says on the side, it says population by age in millions. Okay, key thing right there. So let's just look at the question. It says under 5 years old in 1900. Well, you literally just go to this little section right here where it says 1900 and you under 5 years. Now, what you probably see is that this is around 9 or possibly 10, just like you see on my paper. Well, okay, that's cool. Now let's go ahead and look at the other one. It says 45 to 64-year-olds in 2050. Well, when we look at that, well, that's pretty close to, that's one is right here, and we trace it up, it's pretty close to 100. So that's what you probably wrote down when you answer this. Guess what? These answers are incorrect. Why? Think this through. Give you a moment. What does the graph say? It says population by age in millions. So the answer is not 9, but it is 9 million. That's the difference. So your other answer that you may have guessed, instead of being 10, it was actually 10 million. So the correct answer for that is 9 or 10 million. Now you may have chose 9, you may have choose 10. Doesn't really matter because this is estimating. All right, look at the next one. We said that we had 100, but that's not correct. It would be 100 million. All right, that's what I need you to understand. So when you go to answer this thing, make sure you don't just put the number 9 or the number 6. You need to put it in the correct format. This is million. Okay. Now, moving on. If I can get the paper for it. This actually seems to be, even though this is review, I see a lot of people struggling with rounding. Okay. Rounding is a type of estimation, but in order to know how to round, you need to know the different, what we call place values. So in your notes, it should say place values in that little spot right there. We need to know the different place values. Now, I've provided you a little chart with a set of numbers here, and this set of numbers gives us different place values, all right, as you can see. And so I want you to look at them. Well, we have millions, thousands, hundred thousands, hundreds, tens, ones, tenths, hundredths, okay, and so forth and so on. Now, there's something that you should know. You see the decimal point, and the one directly to the left is the 1 spot. The one directly to the right happens to be the 10th. And then we have the one here is the 10. Okay, the 10 spot. Notice something. You have a tens, you have a tenth, you have a 1, but there is no, repeat after me, there is no such thing as a 1th position. It does not exist. 1th does not exist, okay? I have that issue. I have a lot of students who say, well, this is the 1's position. Like if I give you this number, they tell me that this is the 1 and this is the 1th. That's not true. This position is the 10th position, while this position is the 10 position. Here's how you can tell the difference between whether it's on the whole side of a number or what we call the decimal side of a number. If you hear the word the th at the end, it means that it's a decimal. It's on the decimal side. So if I tell you tenth, you're looking for a decimal. If I tell you 10, you're looking for the whole number side. If I tell you hundredths, and you can probably see the spit coming out of my mouth, you're looking at the decimal side of the number. Okay, and the decimal side happens to be the right side. All right. Now that we kind of got that concept, you also have your notes in front of you, some steps when dealing with rounding. You may have been taught to round up and round down while you were in grade school. I do not like the term round down. Yes, technically that is what we do. However, we do something I call staying the same. So let's just kind of look at these notes real quick and read them. It says, first, you go to the digit that you are rounding. Look at the digit that is to the right of the digit you are rounding. Okay. If the digit is between 0 and 4, the digit you are rounding stays the same. Most of the time you've been told that it rounds down. Don't do that. This is the reason why. All the digits to the right of the rounded digit become 0. Okay? Don't worry. I know you're like, what's this mess mean? It's okay. I'll explain it in a second. If the digit is between 5 through 9, the digit you're rounding goes up 1 by 1. All digits to the right of the rounded digit become 0. And then at the end, after rounding, all trailing zeros end at the decimal number are dropped. Alright? So let's go ahead and do something and kind of explain what all those little rules mean. That's the mathematical way of saying things, but when you see it, it's so much simpler. Okay? So, the first number I want you to do, this is going to be your number 1, is 1345.658. And our instructions tell us that we're going to round to the nearest hundredth, nearest tenth, ones, and thousand. Alright, so let's do the first one, the hundredth. Well, we need to find the hundredth position. Well, according to our little handy dandy chart, this position right here is my hundredth position. Now, what I'm going to do is round this 5. However, according to my rules, I need to look to the number that's directly to the right of it. I need to look at this 8. This 8 tells this 5 to do something. According to my rules, numbers that are between 5 and 9 tell this number to go up. So what happens is this 8 is telling that 5 to go up. So we're going to write this number as 1345.6. The 5 now becomes another 6. And then my last part of the instructions is that all the numbers that are this direction become a 0. So the 8 becomes a 0. Don't say round down. Don't say rounding blah blah blah. This is what I want you to do. Okay? Now, the very last step says this. After rounding, all trailing zeros, which are the zeros at the end of a decimal. So you see this? Here's my decimal. This zero's at the end of that decimal. It gets dropped. Alright? This number has been rounded to the hundredth position. So we just rounded to the nearest hundredth. Let's go ahead and do the nearest tenth. We need to find the 10th position. Here is my 10th position. I'm going to look to the right to this 5. This 5 is going to tell this 6 to go up. So my number is going to be 1345.7. These two numbers here are going to become zeros. Alright, and then the last step is that any numbers at the end of a decimal, these zeros are at the end of the decimal, will be dropped. So I have rounded this to the nearest tenth. Alright, so now let's do the same number, but this time we're going to go to the nearest 1. Well, my 1 position is here. I need to look to the right of the 1 to this position. This 6 tells that 5 to go up. 1, 3, 4, 6. Okay? Then these all become zeros. And then I look at the rule again. It says zeros at the end of a decimal, trailing zeros, get dropped. So all of these get dropped. So now my number is just 1,346. Okay? Now, the last one states that it wants us to go to the thousandth position. Well, the thousandth position is right here. So I'm going to look to the right of it, which is this 3. This 3 tells that 1 to stay the same. So I'm going to put a 1 there. And all of these different digits become 0. Now I have a lot of zeros here, okay? But the rule says trailing zeros at the end of a decimal, all right? Well, my decimals are here. So only the zeros that are in the decimal at the end get dropped. So this number was rounded to just 1,000. The next two numbers I'm going to let you just kind of do on your own. I think you kind of get the point. If you're still struggling with rounding, feel free to contact me. But I'm going to go ahead and just give you the next two problems. Try those on your own, and if you've got some issues, get up with me. I just don't feel like you want to watch a really, really long video. So the second number that I would give you is 2536.312. Do that rounding with that as well. And the next one is when the phone rings a second time. See, this is why you were supposed to cut your phone off while in class. That goes also for instructors. And for some reason, when I'm making these videos, it likes to ring even more. Don't know why. Alright, so the second one that I gave you was 2536.312. The third one that I'm going to give you is 5180.998. Now, this one's tricky, and I'm going to show you why. Just one. I'm going to round to the nearest tenth. Okay? This 9 tells this 9 to go up. Well, how does 9 go up? It becomes a 10. Well, when that happens, that 10, that 1 from the 10 comes over here. So we now have 5181. That 9 became a 10. That 1 had to go over to this place. And all of this is 0. Okay? Now, I told you to round to the nearest tenth, right? Well, what's that mean? Normally, you would just drop these 3 zeros. However, I told you to round to the tenth. That means that this 10th position is important. It's not a trailing 0. So what only gets dropped in this case is this. So be very cautious on that when you come to the crossing sometimes, especially with 9. This is one of them that will kind of mess you up, so be very cautious on that. And again, like always, ask questions if you come across something like this and you don't understand what's happening. Alright, so let's go ahead on to the next page. Talking about ratios and proportions. I don't know about you, but I'm going to cut my light off here because I seem to be getting kind of a bad glare just a little bit. Maybe this might be a little bit better, I don't know. Yeah, it's a little bit better for me. I can see actually. Alright, so anyway, ratios and proportions. Ratios. Basic definition is you're comparing two numbers. Like I can compare, for example, the number of doors and windows in my room. I have 2 windows. I have 2 windows. And I have 2 doors. Alright, I have my door into my room and then my closet door. So I can make this as a ratio of saying 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Or I can rewrite this as 2, this colon means 2. This is another way of writing a ratio, 2, 2, 2, 2, 2, 2, or as a fraction, 2, 2, 2. I just wanted to do that because it's fun to say 2, 2, 2. Alright, now, this is a common way of writing ratios. We can actually write the number with the word 2, or we can write the numbers with a colon. However, we also write it like this. Well, what's this look like? A fraction. Fractions are types of ratios. Alright, we will be using fractions. So let's do something, another type of example. Let's say, for instance, we have a class of 4 girls to 6 boys. 4 girls, 6 boys. Alright, I can write this like this. 4 to 6. I could write it as 4:6 or 4/6. Now, some of you are like, well, Mr. Lewis, can't I simplify that? Well, if you have figured that out, yes, you can. We can rewrite this as 2/3. So our ratio for a class that has 4 girls and 6 boys is actually 2 to 3. Alright? Now that's pretty much what a ratio is. It's just comparing numbers. That's all it really is. However, we have something that's called proportion. A proportion is taking 2 ratios that are equal and comparing them, basically. So if we were to give it the definition, it says compare 2 equal ratios. Alright, where the definition for ratio was just comparing 2 numbers. Alright, so what do I mean by compare 2 equal ratios? Well, this is something that you probably learned in grade school. You know that 1/2, rewrite that, 1/2 is equal to 4/8. You should know this by now, that 1/2 is equal to 4/8. Now, this is a proportion. This ratio is the same thing as this ratio. They're equal. Alright? Another thing that we could say is 3/5 is equal to 6/10. This ratio is equal to this ratio. Now, what's cool about this is, the word cool might not be the right word that you would like me to use. What's aggravating about this, maybe? Sometimes we don't get, well, frankly, let's be honest, a lot of times when I give you a proportion, I'm not going to give you all the numbers. I'm going to give you this. 3/5 is equal to 6/x. Alright, or 3/5 is equal to 6/x. Your job is to solve for x. We already know the answer to be 10 because I just showed it to you. But if I give you this, how do we go about doing that? Well, I'm going to pause the video, clean my board a little bit better, and we'll come back. Alright, hopefully you can see this a little bit better. Alright, now, I have a proportion. My job is to solve for x on this. I have 2/5 is equal to x/20, or like they say 2/5 is equal to x/20. Doesn't really matter how we read it. The biggest problem that we've got to figure out is what's x equal to. Alright. The biggest way that we do this is what we call cross multiply and divide. A more commonly used term, especially in the middle grades, is butterfly wings. And what you're going to do is you're going to take the top number here and multiply it by the bottom number here. So we're going to kind of circle these two. So 2 times 20 gives me 40. Put my equal sign down. And now I'm going to take the bottom number here and multiply it by the top number here. Well, 5 times x gives me 5x. Now this should look very familiar to you. You have 40 equals 5x. This is a very simple equation where you still are solving for x. Well, in order to do that, since this right here is multiplying, and in order to get rid of multiplication, you have to do the opposite, which is divide. We're going to take this 5 and we're going to divide it by 5. And we're going to do that on both sides of our equation because that's the rule of solving equations. Whatever you do to one side of the equation, you do to the other. Well, 40 divided by 5 is 8. 5 divided by 5 is 1, so they technically cancel out. And we get that 8 is x. That's all we're doing with solving this type of proportion is cross multiply and divide. Multiply, multiply, get this new setup, then divide to get your unknown. Alright, so what we're going to do is, that was the first problem. I'm not going to do number 2, and I'm also not going to do number 4 with you, but I will do number 3. And yes, this is a dirty sock. Get over it. Could be worse. else. I mean, I could have used something else, but I don't think y'all would have wanted me to do that. That would have been rude. All right, now, so let's just go ahead and do, I'm going to do number 3 with you. So we have 4 over 5 is equal to t over 6.5. Oh my Lord, there's a decimal. Oh. Look, just because there's a decimal does not mean the procedure changes. I am going to cross multiply and I'm going to divide. So, in order to do that, we do have such things as handy dandy calculators. So, what we're going to do is we're going to cross multiply. We're going to say 4 times 6.5. 4 times 6.5 and I get 26. Then we're going to do 5 times t. 5 times t is 5t. Well, what do I do now? I have to get the t by itself, so I'm going to divide by 5. So 5 divided by 5, that cancels out. That's just going to give me t on this side of my equation. Now I'm going to do 26 divided by 5. 26 divided by 5, and I get 5.2. So my answer for this particular proportion is 5.2. Now, like I said, just because there's a decimal there doesn't mean the procedure changes. Sometimes, especially maybe a little bit later down the road, you may get a fraction that's in there. Procedure doesn't change. You just multiply the number times the fraction. Now you might have to do some little finagling if you don't remember how to work with fractions, but if we have to come to that, we'll cross that bridge as we get there. So don't freak out. Alright, so that page is done. Alright, proportion word problems. Okay. Alright, I'm going to stop here for just a second. When doing any type of word problem, any word problem at all, the key to solving the problem is to stay calm. Stay calm. That's the biggest thing I see is that students get a word problem and they freak out. Don't do that. Okay? Stay with me, stay calm, breathe in, breathe out. Life is good. Word problems suck, but life is good. That's really what I want you to do, is stop freaking out because there's words in it. Now luckily what we're going to be doing now is that these word problems that we're going to do are pretty much the same thing for this type of proportion. And I've given it to you right now, and I've kind of given you a basic guideline, and you want to look at a problem and you want to ask yourself, what do I know and what do I want to know? That's really how you need to look at these types of problems. What you know and what you want to know. So this is how I'm going to set it up. I'm going to make a little statement that says what I know, and the other one's going to be what I want to know. Okay? And then I'm going to kind of draw an empty proportion. Alright, now let's go through this first problem together. It says one small 0.5 kilogram package of cheese contains 5,000 calories. How many calories are contained in a 12 kilogram package? Alright, what do I know? I know that 0.5 kilograms has 5,000 calories. Alright, this is what I know. Alright, makes sense? What do I want to know? What I want to know is how many calories are in 12 kilograms. Now, this is something important. I want you to look at what I gave you. And on this, I'm going to show it on the screen here. It's very important that you stay on this. It says, what's on top stays on top. What's on bottom stays on bottom. What do I mean? In my no side, what's on top is kilograms. So what has to be over here is also kilograms. on my no side. What's on bottom is my calories. What has to be on bottom on the want to know side also has to be calories. What's on top stays on top. What's on bottom stays on bottom. That's how proportions work. Now let's go back to the question. What do I want to know? Well, I want to know how many calories. Well, we're just going to put X is in 12 kilograms. Well, I'm going to put 12 right here. Hey, this looks mighty familiar now. I have a very simple proportion, and I can simply cross multiply and divide again. Now, for the sake of the video, I'm not going to do that. I think you get the idea of cross multiply and divide. 0.5 times X, 5,000 times 12, divide by 0.5. Okay, I'm going to let you do that. Now, ultimately, if you want to pause the video, let's do that. Pause the video for just a second. All right. Now, the answer for this is 120,000. That's what X came out to be. But it's not just the number, it's 120,000 calories. Don't forget the unit, because that's what we were asking for, is how many calories. All right, now, the one thing that you probably did, and I see this a lot, is that you got this number first and it looks too big, because we don't see this type of number in real life. Most of us don't. None of us have a bank account that has this much money in it. Okay, well, I don't. If you do, share some with me. All right, so this number looked really, really big. But if you cross multiply and divide like you were supposed to, and that's the answer you got, well, that's the answer. Trust yourself. A lot of people I see will go back and do this, and then all of a sudden they'll change their number to 120 because that just seems more correct. Why? It's because we don't use 120,000. That's something we just don't see often. But 120, well, that's more accurate to us, or makes more sense to us, because we can carry $120. Okay? So don't let the numbers fool you. All right? So the next thing we're going to do is I'm going to just kind of look at question number 2. Pause the video and do question 2 and on your own, and we'll come back and give the answer. Alright, so for this problem, what did you know? You know that 8 feet was 660 gallons. So you know 8 feet were 660 gallons. What's on top stays on top. So feet's on top, feet stays on top. What's on bottom stays on bottom. Gallons on bottom, gallons stay on bottom. So the question that we want to know is how many gallons are in 3.5 feet. Now wait a minute, Mr. Lewis, that's not what the question said. It said 3.5. 3 1/2 of a fraction. Well, 3 1/2 written in decimal form is 3.5. You're going to find out that it's a whole lot easier to change a fraction into a decimal. And 1/2 is equal to 0.5. This is one of those fractions, decimals, I expect you to know. If you don't know it by now, you need to memorize it. So we changed 3.5 to 3.5 feet. We cross multiply, divide. You should have got 288.75 gallons. All right, so what we're going to do now is I want to go ahead and look at number 3. We're almost done with this video. Go ahead and erase this. And this problem is a little bit different because you don't quite know everything. Okay? So, look at the problem. The compression ratio to a certain engine is 11.2 to 1. All right? If the expanded volume of a cylinder is 56 cubic inches, what is the compressed volume? All right, so let's just go with what we know right now. It says that the ratio is 11.2 to 1. Hey, we can write 11.2 to 1 like this, okay? This is what we know. But wait a minute. 11.2 what? 1 what? I don't know what these numbers represent. Well, guess what? You have a formula sheet. In your formula sheet, you have a series of things under the proportion section, and one of those statements state this: compression ratio. A compression ratio is the expanded volume over the compressed volume. That is in your, words went out my mouth, that is in your formula sheet. So what it's telling you is that this is 11.2 expanded, I'm going to be simple, I'm going to put EX, over compressed. Okay? Now you also have some other definitions in there. You have pulley ratios in there. You have pitch and various other things. So if you come across the problem that uses those terminologies but doesn't give you everything you think you know, use that formula sheet to kind of help you out. And again, ask questions if you get a problem like that and you don't know. All right, so we just found out that it's 11.2 expanded volume over 1 compressed volume. All right, and this is all in what we call cubic inches. All right, so now we know this. If this is expanded volume, what's on top stays on top. And this is my compressed volume. What's on bottom stays on bottom. I can now fill this in. I know that this is 56 and this is going to be X. I'm going to cross multiply and divide again, and for the sake of time, I'm just going to get X is equal to 5. 5 what? Well, you might tell me 5 compressed. Well, that's partially correct, but look at the units the entire problem was in. It was in cubic inches, so X is actually cubic inches. All right, so I want to make sure you understand that. All right, now I'm going to look at your next problem, number 4. This is not really a problem, but it's just something I want you to be aware of because this confuses a lot of people in their homework. I cannot remember what number this is, but it's in your first set of homework, and your job is to create a chart based upon that table. All right, and in this particular one, I've already given you the answers for it, but that's not the... don't get too happy. The answers here are not the answers that you'll have in your homework, so don't get too happy. What I really want you to understand is how the answers are gotten. So look at the very first one. It says, the very first one, A, it tells you teeth on driven gear A, and then it tells you teeth on driving gear B, and then it gives you a ratio, gear ratio of A over B. So for instance, let's look at this real quick. If I know that A is my ratio, and this is the very first problem that I'm looking at, okay? I just want you to see how this answer is gotten. All right? So A happens to be, according to this, 16. B happens to be 2. Well, this says 16 over 2. Can this be simplified? Yes, it can. We know that we can simplify it as 8 over 1. Well, what's another way of writing 8 over 1? Just like you see as the answer. 8, 2, 1. That's how this works. I took this A over B, simplified it, and then rewrote it as that ratio that they're asking for. All right? Now, look at B. B is a little bit different. Okay? B, in this case, you have, you're looking for the gear ratio again, A over B, and you know that A is to be 19, you know that B is to be 6. Can you simplify this? No, you can't. So your final answer is 19 to 6. Look at the next one. We'll see. This time, what it was asking you was for A. You don't know what A is, but you do know what B is, okay? And B happens to be 4. And then they give you a ratio of 3 over 1. Now think this through. How can I go about solving this? I set up a proportion. What do I know? I know my ratio is 3 over 1. it's equal to, well, what's the top number going to be? A, right? It's equal to A. What's the bottom number supposed to be? B. Well, in this case, what is it? 4. How do I solve this? I have 3 over 1 is equal to A over 4. How do I solve? Cross multiply and divide. Guess what you get? You get that A is equal to 12. That's how you solve that one. All right, I'm going to do D with you, and then we're going to call it quits because I think you're getting it. But D is just slightly tougher. Not by much. All right, what do you know? You know that A is equal to 14. You don't know what B is, but you know your ratio happens to be 3 1/2. Well, 3 1/2 as a decimal to make our life easier is 3.521. All right, set up that proportion. The top number represents A, so this has to be A. What's on top stays on top. A, A. What's on bottom? B, has to be B. So I don't know it. Guess what I do? Cross multiply and divide again. And in this time, we get that B is equal to 4. All right. Like I said, those answers are not going to be the same, but I did want to kind of show you how that worked just a little bit because that's a problem that a lot of students have with that particular question. This video is done. I think it's done. Let me double check. Yep, I'm done. All right, so this video is now complete. Remember, if you're on my online class, this is just mostly to help you, give you just a little bit of extra assistance in the matter. And if you're on my campus course, you have no choice but to watch this. Make sure you have my notes on the assigned due date. Okay, make sure you do have a penalty. Make sure you know what your penalty is by checking out the syllabus. It might be different for you for my different classes, so beware of that. That's it. This video is done. Hopefully it was short and sweet to the best of my ability anyway, and I will see you in the next video.